Removing aroma compounds from nicotine extract. At Chemnovatic, we follow our own strict manufacturing standard, STC. The STC nicotine manufacturing standard is the realization of Chemnovatic's vision for the highest standards in nicotine manufacturing. It covers quality, sustainability, traceability, and compliance. Today, we will focus on one particular aspect of this standard, quality. Specifically, we will look at the aspect of removing the aroma compounds found in tobacco leaves that have the most negative impact on the odor of pure nicotine. Learn how nicotine is purified from them in a controlled, multi-stage process. Let's start our journey at the beginning. Nicotine is extracted from tobacco leaves. The most commonly used variety is Nicotiana tabacum. But tobacco isn't just nicotine. It contains many classes of chemical compounds, including carbohydrates, proteins, and amino acids, phenolics, inorganics, terpenoids and norsaprenoids, organic bases, carboxylic acids, and pigments. Today, we will focus on organic bases, which consist of alkaloids and aroma compounds, pyridines and pyrazines. The total content of alkaloids is around 3 to 9% of organic bases, and nicotine is accounting for approximately 90 to 95% of them. It means that the total content of nicotine in the tobacco leaf is around 2 to 8%. The other compounds of organic bases are pyridines and pyrazines, two groups of aroma compounds. Removing these compounds is crucial for obtaining odorless, pure nicotine. The removal of unwanted, odor-impacting compounds takes place at different stages of the nicotine manufacturing process. From pre-treatment, which includes steps such as drying, shredding, and softening leaf structure to prepare the material for further processing, through extraction and distillation. Each stage plays a critical role and must be carefully designed and executed to ensure the production of pure, odorless nicotine with purity up to 99.99%. Throughout the carefully designed nicotine manufacturing process, various groups of compounds are removed. We would like to highlight one particularly undesirable group that poses the greatest challenge in terms of removal: aroma compounds, pyridines and pyrazines. Let's talk about these two groups of aroma compounds. How do pyrazines and pyridines are formed? When tobacco is cured, a wide range of chemical transformations take place. Large molecules break down into smaller ones, which then react to form aroma compounds. Let's take a closer look at this process. Cellulose and starch break down into simpler sugars like glucose. These sugars degrade further into carbonyl compounds. Proteins, on the other hand, are broken down into amino acids and ammonia. When carbonyl compounds react with amino acids and ammonia, they produce two groups of aroma compounds, pyrazines and pyridines. Additionally, pyridines are also formed through the breakdown of tobacco alkaloids. Pyrazines and pyridines are particularly undesirable in pure nicotine, as they can generate strong and unpleasant odors, often described as harsh, burnt, or even fishy. That's why at Chemnovatic, we place great emphasis on optimizing every stage of the manufacturing process to ensure exceptionally pure nicotine, completely free from aroma compounds. Let's break down why aroma compounds need to be removed from nicotine extract. To make nicotine odorless, to reduce toxicity, to ensure the stability of the final product, to eliminate unwanted taste. Now let's take a closer look at why removing pyridines and pyrazines from nicotine extract is so challenging. Curing and pre-treatment of tobacco leaves have a significant impact on the levels of these compounds in the nicotine extract. By the time distillation begins, pyridines and pyrazines are already present only in trace amounts, but distillation is the key step to remove them. Because they are chemically similar to nicotine, it's hard to separate them earlier in the process. Even though they have lower boiling points than nicotine, their very low concentration means they don't form a separate fraction during distillation. Despite these challenges, we have developed a process that allows us to successfully remove these compounds and achieve nicotine with a purity of up to 99.99%. Producing high-quality nicotine is a complex and precise process. Extraction and distillation aren't just about technology. They require deep chemical expertise that enables designing and implementing the optimal manufacturing process. The outcome is nicotine of exceptional purity, colorless, odorless, and meeting the strictest quality standards. All of this is made possible thanks to the STC nicotine manufacturing standard, a framework that ensures consistency, safety, and responsibility at every step of production.